White coherent light is sent through the slits of YDSC. The separation between the slits is 0.5 mm and the screen is at a point 50 centimeter from the two slits. There is a hole at the screen at a point 1 mm away from the central line. Which wavelength will be absent in the light coming from the hole and which wavelength will have the strongest intensity? Now first of all we'll calculate that which wavelength will be missing. Now those wavelengths will be missing whose intensity at this very point is 0. So we'll calculate those frequencies or those wavelengths whose intensity is 0 at that very point. Now we know that for dark fringes n plus 1 by 2 into lambda is given by dy by capital D. So the value of y is given as 1 mm. The value of D is given as 0.5. The value of capital D is 50 centimeter. That is equals to 2n plus 1 by 2 into lambda. Fine. So it comes out to be lambda is equals to 2 by 2n plus 1 into 10 to the power 3 nanometer. Fine. Now we know that value of n varies from 0, 1, 2 and so on. So let's say n equal to 1 first of all. So we get the value as 2 by 3 times of 10 to the power 3 nanometers. And if I put n is equals to 2, then lambda comes out to be 2 by 5 into 10 to the power 3. These two wavelengths come out to be 667 nanometer and 400 nanometer. So these are the two waves that will be missing. Because of this two wavelength, the intensity at this point is 0. So this is the answer. And for the second part, I have to calculate that which wavelength will have the strongest intensity. Now we know for strongest intensity means bright fringe, and for bright fringe n lambda is equals to dy by capital D, that again comes out to be 10 to the power 3. So lambda is 10 to the power 3 by n nanometers. Now again here that n value varies from 1, 2, 3 and so on. So if I put n is equal to 1, then lambda comes out to be 10 to the power 3, that is 1000 nanometer, which is of course is not in the range because our range is 400 nanometer to 700 nanometer. If I put n is equal to 2, then lambda comes out to be 500 nanometer and it is in the range. And if I even put 3, then lambda comes out to be 333.33, which is again out of the range. So the only wavelength that will be having the strongest intensity will be for lambda is equal to 500 nanometer. That is the answer.